Welcome back students. This video is for class 8 chapter number 13 sound, page number 159. It is the second part of this chapter. In earlier part we have seen about what is sound. Okay, so the sound which is pleasant, okay, the which means on your for hearing, which is pleasant to our ears, it is sound, and whereas the unpleasant or irritating one is noise. Next we saw the experiment in which the ruler was held at one end and second one was struck. So while after striking we can hear the sounds. In second case, the rubber band was stretched at two ends and then it was plucked, and due to that plucking, vibration took place, and due to that vibration we were able to hear the sound. Similarly, we saw the example of tongs. When this tongs was vibrated, some kind of sound was heard, and in second condition, when it was immersed in water, the vibrations in water was also observed. Now in second case we saw the pendulum. In pendulum, here it is, this type of thing is called pendulum. One end of the thread is tied and second end is tied to a metal or iron ball, and then the ball was taken here. After that it was left. So after after leaving that ball, it travels in this manner. Okay, so this traveling is called as oscillation, and from starting from here, going here and coming back to again the original place is called as one oscillation, or to or fro. Then we saw the amplitude, frequency and time period. Now in this, we saw that the sound travels in the form of wave, and the maximum displacement from the mean position is called as amplitude. Next was the number of vibrations. Okay, so the number of waves in 1 second is called as frequency, and the time taken to complete one wave is called as time period. And the relationship between frequency and time period is frequency is 1 upon t. Next we saw the loudness. In loudness, we saw the amplitude of vibration, amplitude of vibrating body, and distance. Means these were the three factors on which the loudness depends. Now the first is amplitude. So when the sound is loud, the amplitude will be maximum. In whereas area of vibrating of the body is the greater the area of vibrating surface. Means if you have a big rim of tabla, you will hear more sound compared to a small one. So the surface also matters. Second thing, the distance of the listener. If we stand near to the speaker, we will hear more sound. If we stay away from the speaker, we will hear less sound. So distance also matters. Next is pitch. Now pitch denotes the shrillness or flatness of the sound. Pitch means the in which the, now here is an example of whistle. Okay, so whistle has that more means the thing which pricks our ears, right? It is more irritating compared to the drum. Okay, the drum which we bang. So the whistle has more pitch compared to the drum. Next is next thing is women's and children has higher pitch compared to men. Next we saw that the quality of sound. After that, the musical instrument. There are three types of musical instruments: string instrument, wind instrument, and string and percussion instrument, right? Now in string instrument, those who have strings, right? Now they also depends on a thin string has a higher frequency. A thin string will has a higher frequency, means it can vibrate more compared to a thick string. Next, a short string has higher frequency. Okay, a short string will has higher frequency. And last thing, the more taut the string, the higher the frequency of sound. Means the taut means tight. Okay, if the string is loose, the frequency will be less. If the string is tight, you will have more vibrations. So that depends on this. Next is percussion instrument. In percussion instrument, the membrane of the musical instruments should be tight, and more the surface area, more the sound. Next is in wind instrument, the frequency depends upon the length of the wind pipe. Okay, so we have done till here in the last lecture. Now today we are going to start with how sound travels. That is page number 164. Page number 164. Now, for this to understand, first we will consider an experiment. Okay, first we will consider an experiment, that is activity 13.4. okay, first I will explain this activity, and based on that I will explain this. Okay, so first the activity is, here you can see in activity 13.4, here you can see a glass jar. Okay, there is a glass jar and is having a what we can say pipe. Okay, means here it is a hole, and from that hole the pipe is connected. Now what they have done in this jar, they have placed a cell phone or a mobile phone. Okay, they have placed it. Now using this pipe, the air inside the jar is removed using a vacuum machine. Okay, using a vacuum machine, all the air has taken out from the jar. Now there is no air, means there is a vacuum. Okay, absence of air is called as vacuum. Now inside this jar there is no air, means there is an vacuum. Now what happens is, after doing this setup, we have to give a call or ring on this cell phone. Okay, so when you give ring on this cell phone, what happens, you can see that, means you can observe that as more air is removed from the jar, means there is no air or there is less air comparatively, the sound is heard more faintly. You will hear a very less sound compared to the cell phone if it is placed outside the jar. Means if you place it outside, you will hear a loud sound, and if you place it here, you will hear a less sound. Now why this happens? Because there is no presence of air, means there is no medium present. Okay, or if the air is present, it is in the very small amount. Okay, so from the activity you can conclude that sound cannot travel through vacuum, means sound cannot travel through vacuum. It requires a medium to travel. Okay, means it requires a medium to travel, but can travel through air, that is, it requires a medium to travel. Okay, so clear with this? It means what? Sound requires medium to travel. Now you can see here, yeah, what they says, the now sound travels in the form of wave. A sound travels in the form of wave, right? But how does this wave travels, right? We should know how does this wave travel. So for that I will explain you one thing. Yeah, you can see here, look here. Now this is the form in which the sound travels. Means if a person has said something, okay, if he said something, so the sound will travel in the form of like this. Means if this is the speaker or siren or whatever, okay, if this is the speaker, now the sound travels in the form of wave and it goes to the listener. Okay, if this is the ear, okay, this is the ear, so it comes in the form of wave. But how does this wave travel, right? So now we can say that, yeah, if it is traveling in the form of wave, then why the medium is required, right? Because we have seen that it do not travel in vacuum. Vacuum means absence of air. Vacuum means absence of air. Okay, so it do not travel in vacuum. So why the air is required? Now what happens when the wave is emitted, or when the sound is emitted from a source? Okay, this is a source. Now if a source is emitting a sound or emitting any any noise or sound, what happens? Now the air consists of particles, right? Or you can see the air consists of particle. Now here is the listener. Okay, here is the listener. Now here is the source or the speaker, and here is the listener who will listen the sound. Now you can see the air consists of particles. What happens when the source emits the sound? Emitting the sound means what? Vibrations are emitted. Sound is emitted means vibrations are emitted. So this vibration, now if this particle is vibrating, right, after some time it won't vibrate with that energy, right? The energy reduces. Means if you have made the pendulum to oscillate, what will happen? Once you oscillate it, it will oscillate, and then it will stop. Slowly and gradually it will stop. Means what? After some time the energy decreases, and due to that decrease in energy the motion stops. Similarly, when the particle vibrates, what will happen? The particles are placed very close to each other, right? So this particle will transfer its energy to another. So due to that, means due to its vibration, the another particle also vibrates. Similarly, it will transfer it to another. Similarly, it will transfer. So in this way the vibration travels. In this way the vibration travels, and then yeah, it comes here. So you can see this is in the form of wave. So the pattern in which the vibration occurs actually is in the form of wave. Hence we say that sound travels in the form of wave. Clear? So this is the listener. So this particle will transfer energy to this particle will transfer energy to the next one. This will, so the vibration takes place, and this happens very speedily. Okay, it happens very fast, and therefore we are not able to see, and no, naturally we can't see the small particles in there, but this happens very fast. So the sound which we hear comes to our ear very easily. So this is the way in which the sound travels. Okay, hence to travel sound it requires a medium. Now in vacuum there are no particles, and therefore the vibration doesn't happens. That's why we can't hear the sound in vacuum. Clear? So this is what's said here. Now next is speed of sound. Okay, speed of sound. Now you might have observed when it means when you see a thunderstorm in the sky. Okay, when you see the thunderstorm in the sky in the rainy season, you might have observed that the light come first, then you hear the sound. Okay, so when you see in the sky, you will see the lightning first, then you hear the sound. Okay, so why does it happen? So from this we can see that as we are seeing the light, so light is traveling, right? Now okay, as the thunderstorm has occurred, okay, as the thunderstorm has taken place, what is happening? The sound and light both are emitted at the same time, right? Both are emitted at the same time and from same place, but then too we can see the light first, and then we can hear the sound. Now why does it happen? It happens because light can travel faster than sound. Okay, because light can travel faster than sound, and the speed of light, so speed of light is 3 into 10 raised to 8 meter per second. So the speed of light is 3 into 10 raised to 8 meter per second, or if we expand it we will get as 3 and 10 zeros around it. So 1 2 3 4 5 6 7 8, and it is meters per second. So light travels with the speed of 3 into 10 raised to 8 meters per second in air. Okay, so we can say that the speed of sound is greater in liquids and greatest in solids. Yeah, now as the speed of light is greater than sound, but according to the medium, yeah, now we have seen the speed of light is greater than speed of sound. Now next thing, we should know the speed of sound okay, speed of sound in solid, liquid and gas. Okay, so we should know now the speed of sound in solid, liquid and gas, right? Because when it comes to medium, now as we are saying this sound requires medium to travel, so the medium is naturally in the environment there are 3 mediums, right? Solid, liquid and gas. Now air is a form of gaseous medium. In liquid we will have an example of water, and for solid also we will have an example. For that, let us carry out some activity. Okay, that is activity number, wait a minute, that is activity number is given here. Yeah, here there are 3 activities. Okay, activity 13.5, 13.6 and 13.7, that is 165. So by understanding these activities we will come to know the speed of sound is greater in which media. Clear? So first topic, now in first thing we have to observe in solids, right? We have to observe in solids. For that, let's carry out an experiment. Now consider a table, wooden table. Now what you have to do, you have to bend and place your ear on that table. Means what? If this is the table, you have to bend and place your ear on that table. Now what happens? Yeah, ask your friend to gently tap on the table and at a point of 1 meter away. Now tell your friend if you are placing your ear. Now what you have to do, you have to tell your friend to tap on the table that is 1 meter away from your ear. Now you will observe that you will hear some sound, right? So you will observe that yeah, sound can travel through solid. In next example, here they have given us an activity in which you have to take two empty ice cream cups and you have to tie a thread between these cups. Okay, now one friend will speak from here and the other will listen the thing on the other side of the cup. It means what? The air the sound can travel through the air, right? Because here the medium is air, so the sound can travel through the air. In next activity, a bucket of water is taken. Now you have to just bang the two spoons outside the bucket. What you will observe that you can hear a sound normally, but when you bang it inside the water, you will also hear some sound, right? But the amount of sound which is here when the spoons are immersed in water is less. So we can say that the sound is greater is the speed of sound is greater in liquid and greatest in solid. Means it is more in solid medium. Means in the first experiment when you are banging the table, the speed of sound is much more compared to the liquids. Next is reflection and absorption of sound. Now the sound is having like two characteristics, that is reflection and absorption. Now first we will understand the term what is reflection. First we will understand the term what is reflection. Reflection means what? If this is a surface, if you consider any surface, okay. Now what if you means if you send a light ray on that surface, you will observe the light ray on another surface, right? Means if you take a mirror and if you in that mirror if you send a light wave, you will observe a reflection of it, right? So the passing of the light ray after coming in contact with this surface is called as reflection. This is called as reflection. For this best example is mirror. Now next is absorption. Next is absorption. For absorption, let us consider the example of any wooden surface. On any wooden surface. Now here is a mirror and here we are taking a wooden surface. Now what happens is if you what we can say send a light ray on that wooden surface, you won't see any reflection over here. You won't see any reflection. Means the light ray which you have sent on the wooden surface has got absorbed inside the surface. So this is called as absorption, means no reflection occurs. So for sound also the reflection and absorption takes place. Now reflection means echo. Now if you are standing on a mountain and if you say something, you will hear these are mountains. So if you speak something, you will hear some sound back after an interval of time. So this coming back of the sound is called as echo. This coming back of the sound is called echo. Now the echo means reflection of sound. Okay, echo means reflection of sound, that is echo. Next is in absorption. In absorption means if you say something and it's not coming back to you, that is absorption. In normally if the house is empty, so the walls of the house reflects the sound, so we hear an echo in an empty house. But if you place some what we can say household accessories like furniture etc., you won't hear the sound back. Now why this is happening? Because all this thing, the furniture and other articles are absorbing the sound, so that's why we can't hear an echo in an house where all the furniture and etc., all the things are present. So this is called as absorption and this is called the echo. Now now sound absorption. In this, the sound absorption phenomena where it is used, right? In auditorium, if you are sitting in a theater, and watching a movie, and what if you hear a dialogue again and again, means each and every dialogue if you are hearing it again and again, it will become irritating, right? So for this, the walls of the auditorium or the walls of the theater are made in such a way that they will absorb the sound and they won't produce any echo. So the absorption phenomena is used in auditorium, hospitals, factories, because the echo, here the echo is an irritating one, right? So the irritating sound is known as noise. So this will create an irritating sound, and that will become a noise, and it will create disturbance in the listener. Okay, so that's why the walls are made in such a way that they will absorb the sound. Okay, next is how we produce and hear sound. Now our how we as a human being, how we produce a sound and how we hear the sound. For this we have to study two organs, right? We produce the sound from our throat, throat and mouth, and whereas we hear the sound from our ears. So for that we have to know about the functions of the body parts of our body. First is now how we produce sound. Okay, so for that let us consider an example. Now what you have to do, you have to press your fingers against the front of your throat. So just slightly press your throat, you will and speak something. You will observe that there is a movement or there is a vibration inside your throat. So this vibration is producing a sound. Okay, so this vibration is producing a sound. Now what happens is, due to this vibration the sound is produced from our side. But how this vibration occurs? So in this vibration, the larynx, which is known as voice box, next is vocal cords, these two main organs are involved. Okay, so the larynx situated in the front of the throat. Now here in the picture given on page number 166, figure 13.14, you can see these two things are vocal cord. It is means if you observe in the mirror, you just open your mouth and you will see these organs. Okay, so this is vocal cord, and you will see a pipe, right? We can see a pipe that from which we swallow the food, that is called as trachea or the windpipe. So what happens is you can feel the larynx situated in the front of the throat is responsible for the production of sound. So this larynx basically is responsible in the production of sound. Now two bands of tissue called as vocal cords. Now here you can see these two bands. These two bands are stretched across the larynx. Now these are stretched across this larynx, and narrow slit between them for air to pass. Now you can see narrow slit means this narrow pipe is there which allows the air to pass. So the vocal cords vibrates when air from the lungs is forced through the slit. Means while speaking, when the air is given out from the lungs, right? When the air is given out from the lungs, this vocal cord vibrates, and due to that vibration a sound is produced. Now as I said in the earlier topic, the women and children has higher frequency of voice, right? Now why is it so? Because the women and children produce sound of higher frequency than men, because they have shorter vocal cords, because the size of their vocal cord is shorter compared to men. And we have seen that in those string instruments, when there is a short wire, it will have greater frequency, and if these vocal cords are short, they will have higher frequency, and due to this higher frequency, the women and children has high pitch of sound. Clear? Now this is how sound is produced. Now how we hear the sound? For that we will study the structure of ear, because ear is the organ which is involved in hearing the sound. Now our ear is divided into three parts, that is outer part, middle part and inner part, right? Our ear is divided into three: outer, this is the outer one, next the middle one, and lastly the inner one. Okay, so the outer ear consists of a pinna. Pinna means you can when you when we talk about ear, we can see the part which is outside, right? This type of shape is there present, so this is called as outer ear. Next, the one which we cannot see, right, which is inside the outer ear, is middle one, and at the end it is situated deep inside, and this is the inner ear. Okay, so at the end of the ear canal is a slightly stretched membrane called eardrum. Now first we will see the function of this pinna. Now what this pinna is doing, you can see there are lots of turns and twists inside the pinna. Now what this pinna does, it